Hello friends, welcome to yet another video. Today we'll be discussing about a very important chapter called Oscillations and a few number of questions from this chapter so that you can fast revise this particular topic and score a very good marks. I have tried solving certain number of questions which make sure that your problems plus the theory is covered faster. Watch the video until the end because I have tried giving you certain tips for this year's NEET examination connected to this chapter. So to know all this, watch the video. If you're new to my channel, click that subscribe button and the bell button so that you get all my notifications whenever I upload a new video for you. For all my previous videos, hit the like button. So without wasting any time, let's get started. Let's start with this particular question. The equation of motion of a particle executing simple harmonic motion is A is equal to 16 pi square x equal to 0. In this equation, A is the linear acceleration in meter per second square of the particle at a displacement x in meter. The time period, we have to calculate the time period in a simple harmonic motion. We write down this equation. A plus 16 pi square times x equal to 0. According to the general equation for simple harmonic motion, its acceleration equation should be equal to minus 16 pi square x, which resembles the main equation, which is A is equal to minus omega square x, where A here represents linear acceleration and x represents displacement. So if you compare the equations, you will find that the omega square value will be equal to 16 times pi square, and you know this equation for omega is 2 pi divided by time period the whole square is equal to 16 times pi square, where you take the square root from both the sides, you'll get 2 pi by t is equal to 4 pi. Pi and pi can get cancels, so 2 and 4 cancels to give you t is equal to half. This particular question is half seconds. Two simple harmonic motions are represented by two equations. Y1 as 4 sine 10t plus 5 and Y2 as 5 cos 10t. These equations are the displacement equations for particles oscillating in the y-axis. The two particles separate oscillations are given. You have to find out the phase difference between their velocities. You have to be very careful, phase difference between their velocities. So what you have to do, these are the equations which are given in displacement. You have to calculate its velocities and then find out the phase difference. The displacement equations are given. Y1 is equal to 4 sine 10t plus 5 and Y2 is equal to 5 cos 10t. What will be the velocity values for this? V1, let's call it. We'll find out V1 by differentiating its displacement with respect to time. So we can write this equation as 4 times sine 10t plus 5, where we are differentiating with respect to time. We'll get 10 outside. You'll get it as 40 cos 10t plus 5. Similarly, for the velocity equations for the second particle vibrating, V2 is equal to dy2 by dt, which is equal to 10 is when you differentiate that the 10 will go out, which is giving you 50 sine 10t. Now to find out the phase difference, we have to make sure that the trigonometric functions should be same. So what we basically do here is, along with that, cos has a negative sign over there. When you differentiate cos function, you will get a negative sign. Okay, so you have to make sure that both the functions are having the same trigonometric functions. So what do you do here? We try putting in the relevant equation so that we change this the second equation. We probably write this as second equation. The second equation into a look alike as the first equation. Putting it like this: 50 cos 10t plus pi by 2. Cos of theta plus pi by 2 will give you minus a sine theta. So now these equations are same. Let's call this equation as equation number 3 and equation number 2. So when you compare that two, you can find that the phase difference between the V1 and V2 will be definitely, let's call it delta phi. Delta phi will be equal to phi minus pi by 2, which is the answer. This is the phi and this is the pi by 2. When you subtract both those, you'll get it as pi minus phi by 2, which is the fourth option as the right answer. So we look at the next question. The kinetic energy and potential energy of a particle executing simple harmonic motions are equal. According to the question, they said that they are equal. The ratio of its displacement and amplitude will be, you have to find out the ratio of the displacement and amplitude. Let's call this displacement as x, which can be called displacement, and amplitude using the capital letter A, will write it as amplitude. Okay, now here they have said that the kinetic energy and potential energy of the particles are same. So what we do here is we are going to equate the equations. So we have said kinetic energy of the simple harmonic motion becomes equal to potential energy. What's the equation for kinetic energy? Half mv square becomes equal to potential energy half kx square. We'll put the terms in the same form. We'll make sure that they are substituted in the same way. Half m into v square, you can substitute it as omega into a square minus x square. This equation will be a pretty important equation this year for NEET examination. Okay, which is equal to half k x square. We can substitute in place of k, you can substitute as m omega square. So what you can do is here you can substitute as half m omega into a square minus x square is equal to half, in place of k you can substitute as m omega square x square. So what you will get, this half and half will cancel, m and m will cancel out, giving you an omega exposed. Okay, along with that omega square will come over here. Yeah, definitely omega square cancels out there from both sides. The equation becomes equal to a square minus x square becomes equal to x square. According to the question, you have to find out the ratio of the displacement and amplitude. You are taking the x to the same side. A square is equal to 2x square. Taking the square root on both sides, you'll get a becomes equal to root 2 times x, so that you can find x to a, the ratio of x is to a is equal to 1 by root over 2. Look at the options. Displacement is to amplitude as 1 is to root over 2, which is this answer is the right answer. Now let's look at the next question. A simple pendulum performs simple harmonic motion at about the x is equal to 0 position with an amplitude a and time period t. The period of the pendulum, the speed of the pendulum at x is equal to a will be, you have to find out the speed of the pendulum at x equal to a. This question for calculating velocity will be very, very important. Okay, speed of the particle will be equal to omega into square root of a square minus x square. For a bonus tip, the maximum velocity of the particle will be is equal to omega times the amplitude. When is that going to be possible? When you substitute x is equal to 0. Okay, right. So here the position is given as a by 2. So if I substitute, if x is equal to a by 2, what will be the velocity? You will get the velocity v equal to omega into square root of a square minus x square, but x is a by 2, so you can substitute as a by 2 the whole square. So you will get omega into square root of 4a square minus a square divided by 4. You will probably end up as omega into square root of 3a square divided by 4, also substituted to be equal to root 3 divided by 2 times a multiplied into omega. Omega is 2 pi by t. 2 and 2 cancels out. The time period is t. So you can get the answer here as root 3a times pi divided by t. So the fourth option is the right answer. So we go to the next question. Which one of the following equations here represents a simple harmonic motion? It's a question which was asked in previous year question paper. The only thing we have to remember here connected to a simple harmonic motion is acceleration will be directly proportional to the negative of displacement if x represents the displacement. So acceleration will be equal to some constant. You can call that constant as k times minus of x. So if you look at the different options, you have to make sure that the acceleration is equal to minus some constant into x displacement. So if you look at the first option, you will find that acceleration is equal to minus k naught, can be a constant. According to the question, it is a constant. Into displacement, it is fine. But the second equation is a second order of x. That means this doesn't qualify to be a simple harmonic motion. If you look at the second option, acceleration is equal to minus k into x plus a. Definitely, it can be called a simple harmonic motion. But before that, let's go into the third option and find out acceleration is equal to k into, which does make sure that there is no negative sign there, that doesn't qualify. Then the fourth one is acceleration is equal to k times x, where there also there's a negative sign, so that also doesn't qualify. The only right answer here represents is the second option, which is the right answer. Now let's look at the next question. The equation of a simple harmonic motion or the wave is given by y is equal to, y is the displacement of the particle, that is oscillation on the y-axis, which leads to in turn creating waves. Okay, y is equal to 3, which is the amplitude sine pi by 2 times 50 into t minus x. Okay, where x and y are in meters and t is in seconds. Okay, the ratio of maximum particle velocity of the simple harmonic motion, particle velocity of the simple harmonic motion to the wave velocity, maximum particle velocity to the wave velocity is the question. It's a very important question. Now this question can make sure that you go through different levels of questions in simple harmonic motions. So if I write this equation as y is equal to 3 sine, if I multiply it in the inner side, so you can write this equation as sine into pi by 2 times 50t minus pi by 2 times x. It will lead to like this. So if I correspondingly write down the equation for a simple harmonic motion, I can write this equation like this: y is equal to a, which is here as 3 sine, t is coming, so it should be omega times t, minus x is coming, so that this should be k into x. So from these values, if I correspondingly find out the different terms, you can say that amplitude from this corresponding comparison, you will get amplitude is equal to 3. Then omega will be equal to 2 and 50 cancels, you get 25 pi. Omega is equal to 25 pi. Then k value will be equal to pi by 2, that is pi by 2. So these are the values you get out of this corresponding comparisons. So what's the question? The maximum particle velocity. I told you what's the equation for velocity of the particle. Velocity of the particle should be equal to omega into square root of amplitude square minus displacement square. The maximum particle velocity definitely will be omega times a, where x is equal to 0. So the question here is to calculate the ratio of the maximum particle velocity to the wave velocity. Okay, so this is the maximum particle velocity. Now what will be the wave velocity? Wave velocity will be equal to omega by k. You study in wave chapters. So definitely these two chapters are connected. The particle oscillation leads to waves. So what will be the maximum particle velocity? Let's calculate that. X is equal to omega times a. Omega is given 25 pi multiplied by amplitude is 3. Right? Okay. Now what is the particle wave velocity? The wave velocity will be definitely equal to omega, that is 25 pi divided by k is equal to pi by 2, which will give you is equal to 2 goes up, you will get it as 50. Now it's equal to the ratio of maximum particle velocity to the wave velocity. Particle velocity to the wave velocity. Call it wave is equal to particle velocity to the wave velocity 25 pi times 3 divided by 50. 25 2 times is 50. You will get it as 3 pi by 2. Which if you look at the options, you will find this as 3 pi by 2, which is the right answer. So to conclude with, we have gone through the equation for simple harmonic motion. A is equal to minus omega square x, which is a very important equation. From there, we can also find the maximum particle velocity. Maximum particle velocity, at the same time maximum acceleration of the particle. The maximum acceleration of the particle is A equal to omega square times the amplitude. Omega square times the amplitude, which is a question which can be asked in the exam, but previously it has been asked. So practice the question from there also. Maximum wave, a particle velocity will be equal to omega times amplitude. Very important equation. At the same time, the equation which is there right in front of you, which is the velocity of the particle v is equal to omega into square root of a square minus x square, is also relevantly very important question this year. Then definitely focus on questions from energy, kinetic energy and potential energy question we have already done in the previous question, so go through that also. Right, these are certain important questions, along with the relation to find out the phase difference between two different simple harmonic motions, which can be coming along with in the chapter called waves. So these are certain important parts from where this year questions are expected.
If you like this content, please hit the like button and share with all your friends. With my next exciting video, signing off. Bye.